This is the unofficial guide to electrocution, because by understanding the science behind electrocution, you can make informed decisions as to your working practices and how you approach some scenarios. There's a lot more information in the description down below, including anything I missed, but most importantly of all, demonstrations in the form of links to videos where I'll provide information about what you're about to watch in those videos. I shall also warn you if the outcome was not known. Some of them may be grim. So let's start by discussing what an electric shock is. When people bridge two electrical connections, the voltage difference current will flow through their body. The connection points are usually live connections, which could actually be unexpected live objects. It could be pipes, it could be just exposed random metalwork that turns out to be live. But it's usually the other point of reference is the ambient ground plane around you, the ambient ground. The effect the shock will have depends on how much current flows, but it usually causes pain and muscle contraction. This is because the brain normally communicates with your muscles by electrical signals. And likewise, when you touch things, the nerves send electrical signals back up to your brain. At low current of just a few milliamps, it will cause significant pain through stimulating those nerves, but it won't necessarily affect the control of your muscles. And I would say that probably accounts for 99.99% of electric shocks, the ones where someone's working on something and they go, ow, and they snatch their hands out. It doesn't take much current to cause quite a notable stinging sensation in your finger. But as the current increases, you lose control of your muscles. And as is often described in fatal electrocutions, the hands grip uncontrollably onto things, and it may actually prevent you from escaping from the thing you've touched. The mechanism behind that is that because the electrical current is now overriding the signal from your brain significantly, those people that say, oh, if I was getting electrocuted, I would just force myself to let go. Sometimes you can actually, if muscles are still operating, you can actually drop away. But in reality, you have no control over the contraction of those muscles in your hand. So what actually happens is the current flow stimulates the muscles that are for closing your hand, but it also stimulates the muscles for opening the hand. It stimulates them all. And the winners in that fight are the ones that close your hand, because they're the strongest, because your hands are designed for gripping. So your hands close. If the current's flowing up your arm, it will cause your arm to go up to the chest. The reason for that is because your arms are designed for lifting against gravity as opposed to pushing down. You do push down a fair amount in normal daily life, but most of the work is actually lifting up, so that's the strongest muscles. Strongest muscles win in this tug of war, and your arms go up to your chest. Your head will kick back. Your arms have gone up to your chest. The body, the core of your body, and your legs will go rigid, because that's the normal stance. The muscles are all balanced against gravity. And you will go up on your tiptoes, because that's the strongest muscles in your feet, and at that point you'll usually fall backwards. This is a saving grace for some people, because if they've actually come into contact with wires, if current's flowing to the ground, falling back actually breaks the connection. If it doesn't, if the wires are loose and they fall them down to the ground, it's a different thing. It's not pleasant. The other thing that happens with that current, because it's so completely uncontrolled, it's not uncommon for significant electric shocks to cause really significant muscle damage. Even a modest electric shock it might seem you're over it, but a few days later you'll get sort of that gym workout pain in your muscles. They'll really hurt because they've been stressed quite significantly. But during a shock, a high-level shock, it can actually break bones as well. Because if you're fairly muscular, it pits all your muscles against each other uncontrollably at maximum strength. And it's not uncommon for people who get a hand-to-hand shock to actually break both their shoulder bones. The other thing that can happen is, of course, being thrown into the air. It's not the electricity that's throwing you. If you're crouching down to any level at all, the current flow through your body will make your legs go rigidly straight, but completely with massive uncontrolled force. The muscles will just all be simultaneously driven maximum power, far beyond the point that you could normally control them. And that's what actually tends to throw people into the air. The two, I mean, those things are bad enough, but the two really undesirable bits, the bits that cause death, are your heart, which everybody kind of knows about, but also your diaphragm. Let's start with the heart. The heart is an organ composed largely of muscle, and it's got lots of sections, and they all beat in sync to actually pump blood around the body. It's quite a resilient thing, the heart. When the current flows through it, two situations can occur. Well, three situations. If it was very low current, it might not affect it at all. If it's medium current, it might cause partial contraction of the heart, which is not good because it can knock out of sync. Kind of bad, but kind of a better case scenario, I believe, is when enough current flows, it causes the whole heart to contract at once. The chances are that it will regain its beat afterwards if the current path is broken, because the heart is actually surprisingly resilient. It's very capable of resynchronizing. The diaphragm is an extremely unpleasant aspect of electrocution. The diaphragm is below your lungs, and it's muscles that actually move up and down, and it makes your lungs inflate and deflate. In the event of a significant flow of current through the diaphragm, it locks in an intermediate position, and this means that people can't scream while they're being electrocuted. Now, if you've seen electrocution in the movies, you know the movies tend to exaggerate things, and you might think that's what electrocution actually looks like. So that'll be people thrashing about and sparks and flames and buzzing and the lights all dipping. In reality, that does not happen. The majority of significant electrocutions are virtually silent. You won't get any clue. It's often said that people who have been next to people who were electrocuted said all they heard was like they were working and they heard them go, oh, just a groaning noise. And what that was the sudden current through their body caused their lungs to just basically go into a mid-position state. And they're probably wanting to scream, but they couldn't move, they couldn't breathe, they couldn't force that air out to make the scream. So it tends to be absolutely silent. And the first clues of working next to someone who's been electrocuted are you look at them because they don't answer a question, you say something to them, and you suddenly realise that they're just locked in a fixed state on a piece of equipment. In that instance, obviously you need to break the circuit as quickly as possible. And traditionally, there's that thing about get a big piece of wood and lever them off or hit them with a big stick or something like that. In reality, for technical people like us, you immediately assess the situation. It could be as simple as flicking a switch to kill the power. If power is coming from another source to an isolated piece of equipment, this is just an increasing issue with modern electrical training. The circuit's being crossed. You can kick them off, but keep in mind that if someone's gripping on under full force of a current flowing through the body, that the muscles will be much stronger, gripping much stronger than maybe you could get them off. It depends how they're actually locked into something. In these instances, you could try kick them off. If they're stuck to a wire, you can see something. You could cut it with a pair of snips. You could short something out. Anything to basically blow a fuse or break that connection to get them off. And this is where you might find they just drop to the ground. Then they're like they're fully conscious and they're obviously extremely agitated. And you at that point, I would recommend that you get medical attention. Even if you get a shock yourself of that similar thing that really, an odd tingle's not bad, but if you've got a real whump one that you really feel massive current flow through your body or it knocks you out, seek medical attention. And here's what will happen. It's not really intrusive at all. The paramedics will turn up. They will basically connect you to an ECG unit, a defibrillator. It's all one combined unit these days, I think. And it will simply monitor your heartbeat. They'll probably put the blood pressure monitor on your arm and maybe a blood oximeter on your finger, and they'll just basically monitor you. But in most instances, if you've just picked yourself up off the floor, you have survived. And at this point, it's worth saying that there are organisations masquerading as safety organisations that scaremonger about electrocution and imply that you're going to die. In reality, electrocution is so rare. Electrocution is where someone actually dies. It's electric execution. But fatal electric shocks, electrocution, are so rare that you'll almost certainly make headlines in a newspaper or TV if you die from electric shock. You're more likely to die. If you're a maintenance guy traveling and working on live electrical equipment to troubleshoot it on a daily basis, day in, day out, the chances are your chances of dying on a car crash or a van crash are much higher than actually being electrocuted. But don't get sloppy about it. As you already know, if you've had an electric shock, it's not a pleasant experience in the first place. But suppose you come in a situation that you've just discovered someone who's lying on the floor, or they're still in the state of being electrocuted, and you break the circuit and they're lying on the floor unconscious. Traditionally, the procedure used to be, well, it still is the fact that if there's someone else, tell them to get medical attention immediately, tell them to call emergency services. Or if you're on your own, you're supposed to do it first yourself, and they will guide you into what's actually happening, what you have to do, and just say, I think they've had an electric shock, they're unconscious. It used to be, they used to say, put your finger and check for a pulse, or on the wrist and check for a pulse. That's out the window now. They are basically saying now, just go straight to CPR. And even if you're not experiencing it, it's pressing the chest, just central to the chest, between the nips, basically. Press the chest there, apply decent pressure, and just pump it. And this is because they've discovered that there are rumours, theories that applying chest compression in someone with a beating heart could potentially stop it. That turned out to be a load of crap. If someone's heart is actually healthy, if it's beating, applying that external pressure will not affect, it will not stop their heart. But if it wasn't beating, it will keep the oxygen in the blood flowing through the body. And that is the important thing. Keep blood flowing through the brain, because that stops the brain from dying. It's the first bit that kind of dies, really. If there is somebody else who can provide the breath of life, then that's useful, but it's a second priority to actually getting that blood flowing. So let's take a look at the environments that are probably the most dangerous, the ones where most electrocutions occur. Now, I'm in a dry environment right now. I'm indoors, I've got my Crocs on, I'm on carpet, on wood, that's 3 layers of insulation already. Then that wood is on air, so that's 4 layers of insulation, and to be honest, my hands are dry. And the outer layer of dead skin has a fairly high resistance, but it shouldn't be relied on as an electrical insulator, obviously. The most shocks occur indoors, and they are coincidental. Some people may even, if I touched a live wire now, I would not get an electric shock. I wouldn't feel anything because there's no path for the current to flow. In some instances, if I was leaning against a wall, which was a stone wall that was damp, or if I was standing on damp ground, or leaning against a fridge or piece of equipment, then there is much higher risk of shock. This is where I have to say, I see so many people working in factories, factory workers that have been shown, if this stops working, press that reset button, and they hold the door open of the metal enclosure and they poke around inside. They're basically holding a solid ground in their hand. Don't do that. If you do go into electrical panel to work, don't hold the door open with your hand. Nudge it open with a dry bit of clothing, your elbow, if you have to. The other thing is gloves. If you're working electrical stuff, even if it's dead, always play safe. I recommend gloves, and they don't have to be the utility industry dielectric gloves, those big heavy rubber gauntlets that they use to work live. I don't recommend using gloves like this to routinely work on live connections and twist live connections, but if you're working on electrical equipment, put a glove like this on, this breathable fabric dipped in plastic. It provides an extra layer of insulation between your skin, and a dry glove can actually protect you from getting a significant electric shock. It will certainly, in the case of hand gripping onto things, it's going to reduce the contact area of skin making contact electrical connection. Even just like standard working gloves like this are a good choice, mechanic style gloves. But then You get people that say, oh, I've had lots of electric shocks because they've been working in dry environments, and they weren't really anything special. I guess I'm immune to electric shock. They are not. Nobody is immune to electric shock. The people that present themselves as show people, showing themselves get electric shocks and doing stunts, it's all fake. You're not immune to electric shock. And as soon as these people go into a wet environment, like working outdoors, working on electrical pillars in the street, working on lampposts, working even in the garden on a garden fountain pump, wet hands, wet ground, it changes completely. Suddenly what would have been just milliamps of current flowing through your body will potentially and very quickly become amps of current flowing through your body. And that's when it gets very, very serious. The most dangerous scenarios of people working are people leaning into equipment, because if they do make contact and their body kind of locks up, they're not going to be able to actually pull themselves back out. They might be able to just flop down at the knees and flop out, but if they're actually really seriously leaning into something, the chance of them being able to get out of that situation is low. The other a major killer is people reaching into electrical equipment, reaching between components, thinking they're safe. They're not, going near anything. They touch something electrical, their arm locks in, and they can't get out. They're physically hooked around the metalwork in the equipment, and that is an extremely dangerous scenario. Don't guddle your hands in amongst electrical equipment like that. It's hidden connections may actually cause that situation to occur. Confined spaces. Oh, one of my least favourite. Working in tight areas where you have to shimmy in and you're on a metal surface. I'd say that to combine all these three things, large areas of exposed metal, grounded metal, water, and tight areas, some factory production equipment in food. The food industry is notorious for that. But if you're in a confined space, that's where your body may be found. Just use extra precaution. Definitely dry gloves. Double checking. Only work live if you absolutely have to. More information about that down below. So, reducing the risk of getting a shock. Obviously, isolate wherever possible. In many instances, it's not possible to isolate if you're troubleshooting equipment. I shall cover that more in the description down below. Bit of a sore point actually there. Dry gloves. The gloves I've mentioned can make a significant difference. If you're doing routine electrical work, it's just an extra layer of protection. Even if you've isolated the circuit, it provides that extra layer. Some things that occasionally happen, you see occasionally see workers that wear a glove in one hand and the other hand for finer detailed work. If they're isolated from ground, that prevents a hand-to-hand shock, but it's not an official thing. It's always useful to be aware of your surrounding electrical environment. If there is a lot of grounded metal in your vicinity, if there's water in the vicinity, it's something that traditional electricians do. It used to be really beaten into us at college to assess the electrical environment before working it, and also to expect the unexpected. And this is even more important these days now that training has been reduced to between 1 and 5 days for some workers, as opposed to what used to be a 8,000, 10,000 year apprenticeship with full mentoring. I could rant about that. I shall mention that down in the description down below. But my worst shock I've ever had was unexpected, because I was pulling a control module out of an automatic barrier gate, holding the metal rail. Well, that's my first mistake. Just now I know. I was young. And it was a grounded control box and a grounded barrier. It shouldn't have been live. I pulled it out and it wasn't live until I pulled it out a bit further. It turned out that someone had removed, they'd serviced the box and the circuit board inside that had all the connections on it that grounded onto the case. They'd removed the brass spacer. They'd lost it somewhere, so it wasn't grounded. And also they'd left out plastic spacers that kept the circuit board away from the case, so it was only when I pulled it out to a certain length that the circuit board touched the case. I went backwards, the circuit board went into the air, the controller went into the air, went bang, showers of sparks, lots of people watching, very embarrassing, not a good day. But expecting the unexpected, particularly with things like British boilers and stuff like that, where bad modifications to add underfloor heating can result in backfeeds from other circuits and things like that. Yeah, expect the unexpected. This is where the gloves come in again. if you're doing electrical work and probing around connections. But that is it. So definitely check the description down below. It contains a lot more information and links to those rather undesirable videos that are very educational but not so great for the people in them. So definitely check the description down below.